Hello everyone. Let's talk about a memory management technique called swapping. Swapping is a technique used by the operating system to manage a memory more efficiently. Here's what it does in simple terms. When a program or process becomes inactive, for example, it's waiting for some input or resource, the operating system can temporarily remove it from the main memory. This is called swap out. The process is saved to a space on the hard disk called swap space. By doing this, the memory that was used by that inactive process becomes free and the system can use that space for other active process. Then, when the inactive process is ready to run again, the OS brings it back into the main memory. This is called swap-in. In this way, swapping helps to use a memory more efficiently, allow more process to run, improve the system performance. Think of it like moving rarely used items out of your desk to make a room for things you use more often. That is swapping. Temporarily moving out inactive process to make a space for active ones. Let's take a look at this diagram. Swapping of two processes using a disk as a backing store. This image clearly shows how an operating system manages a memory using a technique called swapping. On the left side, we have a main memory, is also known as RAM. It is divided into two parts. The operating system area at the top, which is always reside in the memory, and the user space below it, where the user processes are loaded and executed. On the right side, we see a backing store, which is usually a hard disk or SSD. This is where processes are stored when they are not actively running in main memory. Now, look at the arrows. The first arrow labeled swap out. It shows the process P1 moved from main memory to the backing store. This happens when we need to free up the memory. Maybe because another process needs to run or because P1 is idle. Next, the second arrow labeled as swap in. It shows that the process P2 being loaded back into main memory from the disk. This happens when the process P2 becomes active again and needs to be executed. This swap in and swap out mechanism is essential because it lets the system handle more process than the RAM can hold at one time. So to summarize this swapping, the swapping out frees up the RAM by moving inactive processes to the disk. The swapping in brings the process back to RAM when they are needed again. It's like temporarily placing a book back on the shelf to make a space for a new one on your desk. When you need the old book again, you just bring it back. Yes, I hope this video will help you to understand the concept swapping in the operating system. Thank you.